So let's start with delegates and events question and answer videos. Before we go ahead and we try to understand delegates, let's try to understand what problems does delegates solve. If you understand the problem domain, then it will be very easy to understand delegates, and we will be able to map how delegate solves a problem and what delegate is all about. So in this video, what we'll do is that we'll first understand the problem, then we will see how a simple delegate looks like, and then we'll try to see that how delegate addresses that problem. So let's first try to understand the problem. Now here's a simple CLS maths class, and this CLS maths class has an add function. And this CLS maths class is consumed in a UI code. So basically, you have created an object obj math, an object called as obj math of CLS maths, and you are calling the add function, and you are getting the results. Now over a period of time, somebody goes and adds a subtract function in the CLS maths class. Now if you want to use this subtract function in your UI code, then you have to again basically call the dot sub method, because you have named the subtract function as sub. So you need to basically go and create the object and call the subtract function. So in other words, any changes in your business object, that is CLS maths, will lead to changes in your user interface code. So in other words, there is a heavy coupling between CLS maths, new functionalities added, and your user interface code. So how can we solve this problem? If somehow my client basically points towards an abstract pointer, and this abstract pointer then points towards the functions, then probably I could be able to achieve, or I will be able to achieve, a decoupling. So in other words, if my client rather than directly touching or directly calling these methods like objmaths.divide or objmaths.add, etc., he just references this abstract pointer, and this abstract pointer internally then calls the divide, add, and subtract or multiplication functions. And this abstract pointer can be created by using delegates. So basically, delegates are nothing but they are pointers towards functions or methods. So a very abstract pointer which you can point towards a function, and then you can invoke it in a very generalized manner. So let's first try to understand how to create a delegate. Once we understand how to create a delegate, we'll again go back to a problem and see that how delegate will help us to solve the problem. Now over here I have a simple example here, and here I have a simple add function, and what we're going to do is that we're going to create a simple delegate which points towards this add function. Now creation of delegate is a 4-step process: declare, create, point, and then invoke the function. So the first thing is you need to declare a delegate. Now over here we are going to point towards the add function, which has an integer as a return parameter type and 2 input parameters which are again integers. So you need to create a delegate by using the delegate keyword, and the return type is integer. It should be same as what the function you're going to create, and some name to it like point to add function, and then basically the same data types as the input parameters. So the first step is you declare the delegate with the proper return types and input types as your function or your method has. The second thing is you create the delegate. You create a reference to the delegate. So this point to add function, I have created a reference here called as myPTR. The third step, you point this reference to the method add. So over here I'm saying myPTR is going to point to this dot add. And finally you invoke the delegate by using the invoke function. So the myPTR dot invoke, I'm passing 2 numbers to it, and basically I'm just showing the output. So I declared the delegate by using the delegate keyword, then I created the reference. After that I pointed to the method for which the delegate was created, and finally I invoked the function. Now let's see this same code through the Visual Studio. Now here's the same sample of the simple delegate which is in the source code. So basically here's my add function, and here's my delegate which points towards the add function, and I have a button click. I have created a simple form with a simple button, and in the button click what I'm doing is I am creating a reference, third step, and then finally I'm pointing the reference to the add function and finally invoking it. So basically you can see that we declared the delegate, we basically created a reference, then we pointed the reference to the method, and we are then calling the invoke function to invoke the delegate. So if you run this, you will see 20 plus 10, that is 30. So this is a very simple example of how delegate works. Now what we'll do is that, now that we have understood the concept of delegates, we will take this delegate concept and we'll try to understand that how is our problem, which we talked about, the decoupling problem, where we had a CLS maths function and we were adding, more functionalities, how that problem can be addressed by using delegates. A bit time. And then when I call the button function, it just gives me the total out. So this value or this data is coming now from the invocation of the delegate. So let's move ahead and try to understand that how this delegate, the delegate, will help us to solve the decoupling problem, which we discussed previously. So here's a CLS maths class, and we have discussed in our previous session the problem related to this class, that whenever we add a new functionality, that is add, subtract, or any kind of other functionalities to it, your client code has to change. So what we have done is, the first step is we have made all these functionalities, these dynamic functionalities, add, subtract, as private. So tomorrow if I add something new over here, the person who is consuming the CLS maths class do not have to worry about it. The first thing what I've done is I have made all my algorithm functionalities as private. The second thing what we have done is we have exposed a delegate outside. You can see that we have exposed a pointer maths delegate, and this pointer math delegate will point towards the operations, depending on what you give him. So if you give him 1, he will actually point towards the add method. If you give him 2, he will point towards the subtract method. So the public function or the public method what we have exposed to call the add, subtract, or any kind of new functionality is nothing but it's a simple delegate. Now in our UI code, what happens is the UI actually just points towards the delegate. So you can see that I've created a CLS maths class, and then I'm getting the pointer. I'm not calling up the add or the subtract function. I'm just calling the get pointer method, which we have created here. And this get pointer method, depending on what operations you give him, he will actually invoke the functionalities. Okay. So now if you run this, so let's run this. So now here's the application which is running. So if I'm provide him 1, it will do addition. If I provide him 2, it will do subtraction. So let me just take up 20 and 10. So I'm providing him as operation as 1. Okay, so it will do addition. So it has just added 20 and 10. Now let's provide 2. It will do subtraction. So 20 minus 10. So the user interface over here now doesn't have to really worry about what kind of functionality it is calling at the backend, because it is just pointing towards the pointer, the delegate. It is not actually calling up the add functionality or the subtract functionality. Now let's say that this CLS maths function will change now. So in other words, let's go ahead and put up a division and a multiplication function. So we already added a subtraction and an add function. So now we are putting 2 more algorithms here, multiplication and division. Now any kind of changes which I do here, doesn't affect the UI. Why? Because the UI is pointing towards a pointer. So if I run this project, first let's compile this, rebuild solution. And now let me go and run this. So F5. So we have added 2 more functionalities here. So let me take up 20 and 10, and let me say 3, because 3 is for multiplication. Evaluate. So it has multiplied. I'll use 4, so that will actually do the division. So you can see that we have added multiplication and division, but we have not changed a single line of code on the UI side. So what has basically happened actually? Basically we have exposed just the delegate, the abstract delegate. So this delegate helped us to decouple our algorithms what we add here, with the external UI. So in the nutshell, what we have done is basically your UI is now referencing an abstract pointer, and this abstract pointer is pointing towards these functions. So it's pointing towards functions which has basically 2 integer